Thank you.
Okay. Why don't you share your screen in the meantime?
Sure. Yes. Yes. Right away. Yes. Okay.
And in the meantime, we're going to wait for people to log in.
Okay.
It usually takes a minute.
Yes. Okay.
Okay.
Well, just maybe.
Okay. Right. Well, let's get started.
Okay. Yep.
Hello, everyone. We're a bit late. We had a little technical glitch. In any case, welcome to today's Gala webinar. My name is Isabella Massardo. I'm content strategist here at Gala. And today we have Rafał Jaworski from XTM International, and he's going to deliver a very techy presentation. We will have a Q&A at the end of the presentation. Feel free to use the Q&A button to enter any questions you might have for our speaker. And I invite you to do it throughout the presentation as you think of them. If you use the chat, please note that you can select who your message goes to. So if you select panelists and attendees, you can chat with other attendees. Otherwise, only the presenter and myself will get to see your greetings and your comments. And you can also use the chat for any technical queries, and I'll help you troubleshoot. Right, Rafał, I'm going to leave the virtual stage to you.
Okay, thank you so much. So first of all, thank you for having me. Thank you for the invitation to have this wonderful webinar. I'm really honored. I'm really thrilled to be able to talk to you about what kind of achievements we did lately at XTM, because I feel that their nature is more general, and a lot of people can benefit from the ideas that we followed and that led us to achieving some very nice results. So I'm here. I'm Rafał Jaworski. So let me just share a few basic information about myself. So I work as a linguistic AI expert at XTM International. So we are dealing with a huge translation management system with computer-aided translation capabilities. And I'm the one who's leading a team of young and talented researchers and developers who are focused on providing the NLP, natural language processing, and AI capabilities to the CAT tool. Apart from that, apart from my work at XTM International, I'm also a university lecturer and researcher at Adam Mickiewicz University in Poznań, where I am located right now, because I'm speaking to you from my office in Poznań, my university office, because just so happens that Thursdays are my university days, and I just finished one batch of classes, and it's not my last batch of classes today. So that, but I'm very happy to be able to speak to you about research and about the achievements that we did. So the title of my presentation is multifaceted translation analysis, with the subtitle "Putting it all together." And what it is that we need to put together, what is this all the things that we need to put together, is the focus of the first topic of my presentation. Because right now in natural language processing, in all those research, in all the cutting edge technology being developed in the field of natural language processing, we deal with big data. And well, I know it sounds kind of cliche to use the term big data. The term big data is getting old right now, right? But it is the big data era. I'll just underline it, that we are dealing with the amount of data that we haven't been able to deal with such large amount of data never before. So right now, we do have the data because we've had the data, but by itself, for about 10 years. I'm thinking about projects like Common Crawl, where the entirety of the explorable internet was downloaded in text format, right? The project is still going on. And we are talking about terabytes, hundreds of terabytes of textual data, right? Uncompressed textual data. And we've had the data for quite a long time, but it was only quite recently, I mean, 4 years ago, when the data was put to an actual use. And more on that in the next topic. Like, for example, we are now experiencing the growth in end-to-end solutions. By end-to-end solutions, we mean, well, in AI, we mean computer programs that deliver a certain functionality completely with the use of AI mechanisms. For example, machine translation. Neural machine translation is a good example of an end-to-end solution when the whole translation process is carried out by a machine. Also, we can have, for example, chatbots. We can have content generators. We can have all the magical programs that simply replace a specific human task. Of course, the quality of those varies, but more often than ever, the quality of such tools is kind of acceptable under some scenarios. I've seen scenarios in which machine translation is used as the only source of translation in translation projects, and it all works quite well, right? But apart from that, apart from all those neural big data tools, we have big data fueled language analysis tools. And that's a kind of area that I might say that in the research world has been neglected lately, unfortunately, because at the beginning of the whole natural language processing research, actually it was believed that language analysis is the only tool that is able to provide any solution, like translation, for example, machine translation, that is. It was then believed that it's not really about language analysis, it's all about the big data, that the abundance of data will overcome the rules and the thorough analysis of language. It was believed that data will get you everywhere. But right now, especially at some occasions in some functionalities, it's the big data is just not enough, right? What you need is proper language analysis. And what I mean by language analysis, for example, it's always a pipeline. It's always a series of different processes, different mechanisms that are used in natural language processing. One of the first being the operation of stemming, that is to interfere to for example, to guess what is the base form of a certain word. Like as you can see in this example, like you have the words consult, and you have consultant, consulting, consultative, consultants. That phenomenon of derivatives is clearly seen in this example in the English language, but it's even much more common in languages which rely on declination, on conjugation, and different and are morphologically richer than English. So stemming is an operation that you're doing in the analysis. Then you jump into lemmatization and disambiguation when you are guessing the correct, the actual word that is being uttered in a textual sentence. Like in this example, you have the sentence, "I like to play tennis from time to time," or "I saw a wonderful play yesterday," and the first utterance of the word play is a verb, the infinitive form, and the other is a singular noun. So you also need the analysis tools to be able to infer that that these things are different. So you cannot really use as a dictionary, right? Because the dictionary will only give you one of these interpretations. Then you dive even deeper. You have tools like dependency parsers that can basically build the whole grammatical structure of the sentence. And luckily, the research is still ongoing in terms of dependency parsing, in terms of all the more thorough language analysis tools. And it's my personal belief that we cannot really do without those tools under certain circumstances, under the pressure to deliver a thorough linguistic solution. So we have this fueled by big data, and we have other solutions, right? So as you might have, well, if you have ever heard me talking, sorry. Right. If you ever heard me speaking at a conference or one of my webinars, there's a good chance that you have heard about interlanguage vector space, which I will mention very quickly during this webinar too, because that's a kind of tool that provides some other kind of information than the language analysis tools. So this is research inspired by Google research in short, and it is based on the analysis of large amounts of data. So again, big textual data, which is used to produce vectors. And in this specific scenario, the vectors are a series of numbers that represent words. What's important here is that different words are represented by different numbers. Okay. The solution itself was then developed, right? Because what the vector space does is simply converts words to numbers. But what's been done afterwards in the research field was the extension of this idea to span across languages. So you not only have a vector space in a single language, but you are dealing, for example, with 157 vector spaces for different languages. And what you do is you use mathematical methods of comparing the numbers, and you by doing that, you're computing probability of one word being translation of another. And that's a kind of achievement that's very versatile, and it lets us analyze translations, analyze words by using mathematical methods originally designed just for the numbers. So how does it work? Well, in short, right, you can see it as the following. You have the vector spaces here marked as X and Y, right? So you have the reddish pink vector space for the English words, in which all English words are represented by dots, right? And in turn, you have the blue vector space for Italian words. These two vector spaces are in complete different parts of the plane, of the geometrical plane. They don't overlap, they don't look similar, because they represent different languages. But by applying some mathematical methods, what you can achieve is the following. You can actually align those two vector spaces. You can convert those numbers, right? In the algebraical terms, you translate the numbers, right? So the word translate also exists in mathematics, right? And what you get is a result where the points which represent words which are similar are actually close to each other and are mathematically close. Right. So you can actually model the similarity between words with the similarity between numbers, and the similarity between numbers is a well-known mathematical tool which is ready to use to simply compute the similarity score. As a result, we get the following. we've done some tests. Well, we've done a lot of tests actually, but we've done some tests on languages that we know at least a little bit, right? And we checked, for example, what is the probability that the word gatto is an Italian translation of the English word cat, and we got the similarity of almost 70%, which at first puzzled us a little bit because we expected it to be close to 100%. But then we discovered that it's actually not a matter of 100%. No two words that we tested had the 100% probability using these measures. So we adjusted the results, and basically we treated the 70% match as a very high indication of these two words being each other translations. Actually, 55% was also enough to consider that the word gatta, which is Italian for a female cat, can be treated as also as the translation of the word cat. Well, the similarity right here is a bit lower than in terms of cat gatto. That's simply because the form gatto seems to be more frequently used in the Italian text, at least in the Italian text we use for the training. So the form gatta being more rare was assigned lower similarity. But then when we tried, well, of course, we confirmed our intuition that it works for the actual translations, but we also needed this mechanism to discern between actual translations and not translations. So in the second task, we had cat and giorno, which is the Italian word for day, which we had low similarity for. So, but still not zero, right? We discovered that this will never give us scores like 0 or 100%. It's always somewhere in between the two. The probability of the similarity for words, for the pair of words not being each other translations, was significantly lower. As you can say, for day, as you can see, day and fuoco, right, which is fire, is also low, while day and giorno, which is actual translation of the word day, gets a higher similarity. Normally, well, we say that the vector space is limited. Well, it's fed by the corpus, right? The text that is used for training. But if you get a large enough corpus of text, you can see that vector space can capture both semantic and syntactic similarity for a pair of words. So we are talking not only about computing the probability that two words are being each other translations, but we can also compute the probability of words being synonyms, right? Having some common semantic features, or also we can actually see that words being syntactically similar, like adjective and adverb, apparent, apparently, are close in this vector space. Comparatives like great, greater, greatest are also close to each other in those vector spaces. So we're talking about the possibility of analyzing different types of relations between words by using mathematical numbers, and that's kind of magical. That's the kind of magical mechanism that we have. But let's now focus a little bit on the applications of the said mechanisms. I mean, both the language analysis tools and the interlanguage vector space. So interlanguage vector space, its main functionality being the ability to compute the similarity between words, can be naturally used to solve the problem of figuring out the word alignment problem, as seen in the following in the example in the slide. We can have an English sentence like, and the program has been implemented, right? Translated into French, Let me just apologize for my bad French speaking skills to all of you who speak French. So le programme est mis en application, right? So that's the French rendition of the sentence. And in the slide you can see that the problem of aligning on the word level is by no means trivial. You have some strong matches like the to le, program to program, right? You have been and at, right, which is at. I'm not really good at speaking French, but you have some strong strong matches between those words. But also you have the word and, which happens to be only on the source side in the English sentence, and it's not matched to any words on the target side. And that's quite normal in translation. You can see, I'll show you some other examples for that specific phenomenon. Also, you have the word implemented, which is rendered by 3 words in French. You can also always have it the other way around too. You can have one target word, which is matched to more than one source word, and that's the kind of thing that needs solving before we get into functionalities relying on word alignment, which I will mention later. But what we are after is to figure out the word alignment for any languages there can be. So we did actually we did some experiments, and we did experiments with languages for which we did not have too much text resources, like the Indian language Marathi. And just by using interlanguage vector space, we actually managed to match the words. And then by using Google Translate, we verified that this is actually these are actually quite good matches. Same thing we did for Canada, not to be confused with the country Canada. But there is a language also in the one of the Indian languages. So we did some experiments on this language too. So word alignment with interlanguage vector space and with language analysis tools can be actually quite effective. And what can we use the word alignment for? That's a good question, because I never referred to why we are doing this. So this is it. So these are the actual current and future plan for future applications of word alignments. So what we have, for example, the functionality of bilingual terminology extraction, in which we have the list of terms in the source language. We have their translations, but these are not translation of the terms, but we have the whole translation memory, right? We have a corpus, if you will, a bilingual corpus, in which the terms are located, but the translation of those terms are not highlighted in this corpus. So what we can do is, by using word alignment between the source and target language sentences in the corpus, we can actually perform some bilingual terminology extraction, that is figuring out of the translations of the terms. Some other thing, what we can do, that is during the translation, you might have encountered, well, when doing some translations, sometimes that in the source sentence you might find some technical marks, some technical symbols, like, for example, HTML tags or anything technical in the source text, that people tell you that it shouldn't be touched, right? It should be copied and pasted right into the target sentence in the correct place, right? Like, for example, it's typical that in source sentence you have some HTML tags which surround a certain word. And these HTML tags are normally used to highlight it, for example, when presenting the word. And then when you're working on the translation, you put in the translated sentence, and then you need to manually copy those HTML tags to the target sentence so that they surround the proper word in the target sentence, right? It's a very tedious and time-consuming work, and also it's in most of the cases it's translators feel that it's not their obligation to do so, and that's perfectly understandable. I mean, the technical symbols should not be the problem of a translator when working on the translation. So what we have at XTM is the functionality of automatic placement of those HTML tags and other elements in translation, and for figuring out the correct place where to put those tags, we use the word alignment. Also, computer-assisted review, that's the kind of thing that we're working on. And what we do there is we analyze the translation and we look at the words which are not matched. Like, for example, in the example that I showed a couple of slides ago, you had the word "and" the program was implemented, right, in English, and the French translation lacked any mention of "and," right? So it did not start with the words "at," right, in French. So that's a potential translation error, right? Leaving out a word untranslated. So these are the kind of things that we will highlight automatically, and that's a functionality that will be fueled by the word alignment capabilities. And now let me get into how exactly we get these matches. I mean, these word alignments, right? So how do we perform the word alignment? Because that's the kind of thing that's also not so trivial, especially given the fact that we have multiple, as we call it, facets, right? Hence the MFTA, right? Multifaceted translation analysis that's in the title of this presentation. So we have a lot of data, right? And we have to put it all together to provide the functionality of the word alignment. So we have those stems, we have lemmas, we have part of speech tags from a part of speech analyzer. We have dependency relations from dependency parser. We have dictionary data. We have this interlanguage vector space. We have also surface features that we can compute quite easily with the use of a computer program. We have position in sentence. We have all the information we can get in the form of different facets. And what we do is we put it, in the multifaceted translation analysis. We put it all together and we get something like that. We get a large table in which in the first column, we have the source words, and in the target column, in the first row, we have the target words. Okay, and when the rows and columns cross, right, there you have the computed overall probability of these specific words being each other translations. So, for example, in this example, we have they know about the overproduction problem. Ils connaissent très bien les problèmes de sous-production, and as you can see, the overproduction and superproduction got a very high it's not actually the mean of probability, but it's a score, right? It's a matching score of 1.7, which is pretty high. So it's a verified good match. Also, the words problem and problème were matched with quite a high score, right? And in blue you have all the other matches that are in this sentence. And right away here you can see that in the French version you have two words, très bien, right? Very well, which are not matched to anything, and that indicates a potential translation error, because the original sentence was they know about the overproduction problem, right? And the French sentence read something like they know very well about the overproduction problem. So this very well was an addition done by the translator, presumably. So this is the kind of thing that we feel that needs to be highlighted as potential problem with the translation, and needs to be addressed during the quality assurance phase of the translation. Right. To sum up, those factors, those scores are computed for each pair of words from source and target sentence, and we kind of weigh. We put it on scales, right, on a virtual scale, and we are weighing those factors to allow the modeling of language phenomena. For example, the factor of the position in the sentence can have a large weight in languages which are which have the similar syntax, but then we have languages like German in which the position in the sentence for verbs can be very tricky because the verbs can be put at the end of the sentence, right? So we can model such phenomena, and the general principle is that we match together the words which present the highest score of matching between each other. And I'm giving you I'll not go through that in too much detail, but I just want to show you what it looks like in real life scenarios, with this sentence coming from the European Union translations. You can see that words are generally matched to each other, but not all of them are matched very well, because for some language phenomena which just prevent them from being matched directly to something. But we still have a backup mechanism by using phrases, by using the syntactical phrases which come from language analysis, and we can perform matching on phrases, right? Like, for example, priorities of European Union policy as a nice little phrase in the English language, nouvelle prioritaire, and so on in the French language, which is an approximate phrase match. So we go one step beyond. We not only align words to each other, but we are also aligning phrases, and that's the sum up of what I said. In some cases, it's just impossible to match words directly, but in these cases, we can still infer some matching between phrases, and that's simply because some words, it's quite natural that some words don't have direct counterparts in the translation. So we started the analysis of different elements of the sentence, let's say. So not only words, but different elements, being phrases, being compound tokens, being compound words, and many different elements of the sentence. And this way we ended up with this. We kind of exchange one word for another. Instead of multifaceted translation analysis, we now like to call it multi-element translation analysis, which quite incidentally forms quite a nice acronym, META, with which we will label the technology from now on, and more things will be built upon that, because META kind of reflects this idea that we started with language analysis. We added up ILVS, we added MFTA, we added then the phrase analysis capabilities to form META, and this is the kind of approach that we will assume from now on, that we will build one solution on top of another. So each new mechanism, each new extractor will contribute to this whole system of natural language processing. And this is my answer to the question, how to combine all the data together. What you need is a framework that is able to grasp all the data that it's able to use, and then it's not only ready to analyze the data it has today, but it will also be ready to analyze all the data that will be provided later, but the mechanisms that have not been invented yet. Right. Okay, so this is what I had to say. So thank you so much for your attention. And now I'm open for the questions, and I can see some
Yes,
already.
there is a question, and actually I'd be happy to open. Let me see if I can do that. I can open the microphone so that we can talk. You can talk directly to Rafał if you want. Oriana, you had asked the question.
Yes, hello.
Hi.
Hello.
Thank you for your talk. I was wondering, when you showed the MFTA scores, are there kind of probabilities? Like, I was surprised to see scores that were higher than 1.
Right. It's a good question. So guilty as charged. They're meant to be probabilities, but it evolved into not quite the probabilities. Actually, that was inspired. That there's not a trick that it's new in mathematics. When back in the statistical machine translation days, it was quite common to start with a probability-like model and then adding some new factors, and then we just look at it and say, hey, they don't add up to 1. So what, really? And this is how for example, the log linear model was developed, in which it does not really matter that the values are not normalized between 0 and 1. They are still comparative because they are in the same, say, measurement, right? And you can still compare them. So we started out with probabilities, actual probabilities, and they evolve into, generally speaking, scores.
Thank you.
Okay, great. Any other questions? Just raise your hand and we can ask, and we can open the microphones. You can speak directly to Rafał. As a former translator, I'm very happy that the automatic placement of tags in the correct place is a possibility, because I remember correctly, it was quite a waste of time sometimes.
It was,
an annoying
yes.
task, yes.
Yes, what we have is we are getting very positive feedback from people using this feature, just because it relieves them from this very tedious task. So we are bringing a lot of joy, and also
yes, you are.
and also not only that, we did actually some calculations, and during the course of 2 months, we measured that this functionality on our main server on the XTM cloud was used 1.3 million times, right? Which kind of translates to the feature being used every 4 seconds, 24/7, right? So someone clicks on the button and gets their tags. And what's even more optimistic is that 98% of instances of pressing of this button did not require any post editing in the translation, because we kind of recorded, right? If someone post edited, we just made a note that this result had to be changed, but it had to be changed only in 2% of the cases. So it's kind of
that's very good. That's very good. Yep. Yeah. And while we're waiting whether there are other questions, I think that the most logical question right now is, what are the next steps in developing this technology? Can you tell us a little bit, or is it still top secret?
Well, some of them are kind of secret, but I can well spill the beans a little bit, right? So we are putting a lot of effort into this computer aided review feature. So you'll be able to see you'll be able to see how an artificial intelligence mechanism watches over another artificial intelligence mechanism, by which I mean machine translation. So we will be looking for problems or errors caused by machine translation, which kind of slipped into the final translation, right? And were not noticed by the translator. That's because NMT is deceiving. It looks very well. Those translations are smooth, deceivingly smooth. And what we need sometimes is to have some mechanism to signal a potential error. So that's the kind of thing we're working on. And and
that would sorry to interrupt, but that would probably help the post editor as well.
Of course, yes, we are very focused on the post editing, on the QA, all possible QA checks. Some of them being technical, let's say, involving lookup of a dictionary or things like that, but also using AI to the full, I would say.
Interesting, very interesting. Thank you. Let's see whether there are any other questions. I don't see anything. It was a very interesting presentation, even for me.
Thank you.
That I know very little about it. So thank you so much, Rafał. And thank you to everybody who attended. Before you log off, remember when I close the webinar, you'll see a post-webinar survey. So please fill it in and let us know what your interests are, future topics, but most importantly, give feedback to Rafał and his presentation. And the next webinar will be on March 24th. It will be something completely different. We'll talk about organizational culture as the key to unlock transformational change. And of course, don't forget our annual conference in San Diego and virtual from April 24th to April 27th. And Rafał will be presenting there, both in person and a virtual session. So,
but not at the same time. But
not
yes.
at the same time,
right? Yes, yeah. But I'll be there. Yes, I'll be there to shake hands. I'm really thrilled.
Yes,
to
exactly. So if you can make it, it would be great to see you all. And for now, once again, Rafał, thank you so much, and everybody.
Thank you very much for your attention. Thank you. Thank you.
Have a good day, everybody, or a good evening, and we hope to see you soon. Bye.
Bye.